Back and forth.
I went to put it on the pump. I used to find the external hard disk and I put it in the then it had no pictures and videos from my mom.
Never pay that.
Why would I ever pay?
Why is this not working?
You know, I remember the 17 this was
Dude, what the heck?
It actually happened.
There's a trick.
What's the trick?
It's very simple.
Go on.
Call Mr. Combe and let him like do his magic.
Blow on the inside and it'll work.
It's like magically, like whenever he comes, shows, doesn't even touch it, and it just starts working.
No.
And we're on diagnostics. There we go.
No. No, there's two of them, but both of them don't seem to be doing anything. Not cool, dude. Well, is the computer working? Maybe I can use the computer. Do we have computers?
Maybe it's one of the buttons over there. USB type E.
There's only one. Come on.
Something happened.
I don't need no column. Right. I'll need to ask them to fix that. Okay, let's look up, guys. Sorry, it's a combination of broken projector and broken laptop. Oh, yeah. Life sucks, doesn't it? Right. Tangents and normals. Now, these are things we already know about because we've done them in coordinate geometry. We've talked about tangent lines, and we've talked about, maybe we've not talked about normals. I don't remember. I don't think we have we? No, okay. So here's an example of a tangent line. We call this a tangent line. And would anybody know what the normal is? It's perpendicular to it. So in this picture here, this would be where the normal is. Okay, so let me scroll down a little bit. Where's my... Oh, now my writing pad's starting to break. No. Squeeze every last penny out. Okay, so let's have a look at an example. How would we find the tangent line to y equals, let's say, x squared plus 3x plus 2 at the point 1, 6? Now, we've seen one method. What method was that?
First
No, before that. Before that,
What?
discriminant. We could use discriminant. But we realise that's a very messy method. Well, actually, we can use derivative. Because what does the first derivative give us? The gradient, the slope of the tangent. So, here, if I want the m, that would be dy dx, which would be 2x plus 3, and here x is 1. So that would be 5. Great, so now we have y equals 5x plus c. That's the tangent. Although we still have to find c, right? And how do we usually get our c? Subs that in. So you get 6 equals 5 plus c. So c equals 1. And here's our answer. Our answer is y equals 5x plus 1. Now you can appreciate that that's much easier way to do it than what we did a couple of weeks ago. So once you write that down, I'll give you something to try before continuing. So there's our first example.
Sir,
Yeah.
instead of doing this and finding C, is it okay to
Yes.
use the
Yes. 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 You can say y minus y1 equals m times x minus x1. That's what you're going to ask me, yes? Yes. You see? I know all. Okay. Got that?
No.
Not yet? Okay. I see a couple of people missing. Where's what's his face? Yeah, yeah. He didn't look so well yesterday.
He is in a horrible state.
Is he? He wasn't looking great yesterday. Or, well, he was looking worse than normal, you know.
I haven't contacted
Okay.
yet, so I don't know what's going on.
Don't worry, he's not going to hear this because I'm sure he's not going to watch this at home, right? If you're watching this, Mahmoud, I want you to comment in the video now.
What time is it now?
Yeah, this is at the 7 minutes now. We'll see if he posts a comment then to this later. Okay, do you have that one? Now, what I want you to do, I just want to make one tiny change to this question. I want to see if you can figure out how the answer is different. Instead of tangent, I want you to do this. Find the normal. And remember, the only difference is that the normal is perpendicular, okay? So I think you can do this because you can remember what's special about being perpendicular. So see if you can do this version of the question.
So the second derivative?
No.
Just 1 over.
Yes.
Do we change the sign? I forgot.
I won't tell you. Yeah.
I just realized I didn't understand something what you just did.
Yeah.
Okay, fine, we did y dx.
Yeah.
From that.
Yeah.
Why did we do
Yeah.
so sorry.
Because x is 1.
Minus 1 over.
Oh, okay.
Yeah.
Oh, so that would be divergent.
Correct.
Okay.
Huh?
Then we just do that.
Yeah.
That's a good question.
Thank you.
Think you got the answer? Some people have it?
Negative 1 over. I lost my participation.
Where does the 5 come from? And equals
He just asked me. Go tell him, Mahmoud. Oh, sorry, Mubarak. I have him on my mind. Go on.
X is 1. It's not in the 1. So 2 plus 2.
Right. Are you ready to see the answer for this?
Yes.
Yep. So, I hope some of you realize the only difference is in the m. So in the last question we said the dy dx, what was it? 5, wasn't it?
Yeah.
So the only difference is the m is minus 1 over 5 because it's perpendicular. So y equals mx plus c, 1 5. So, yeah, 1 6 is it? So 6 equals minus a fifth plus c, so what's that, 31 fifths? Yeah, so y equals minus a fifth x plus 31 fifths. That's the normal, that's the line perpendicular to it. Yeah? Okay, we'll do another one now. That's a quadratic, but let's do something that isn't quadratic.
Question.
Yeah,
How would we find this without doing the tangent first? Can we
you
find
can't. You have to get the derivative.
Oh.
Yeah.
But you don't have to relatively find the other.
No, you don't find the other c,
Yeah.
so,
You got to find the n.
yeah. Okay. Got that? Yep. Right, let me give you another one that isn't quadratic. So, same thing again. Find the equation of the tangent line to y equals, let's just make this e2x at the point where, let's say, x, what did I use in the last one? 1, wasn't it? So we'll just say x is 2 here. Okay, try this one now.
Is it the derivative 2e2x?
It's 2e2x, correct, yeah. You got an answer? Impossible to get an answer?
No.
Oh, good. Got an answer? You're just not sure, huh?
Yeah. It's so weird.
Was on the
Okay. Ready to see it? No, not yet.
Do we involve log as well?
We do not. Not all of life's problems can be solved with log.
Because at the end you use the kind of just you think it's a lot and
It was worth a chance.
But then I don't know what to do.
Yeah. Do you have a formula that tells you what the y is if you know the x? Huh? Do you have a formula that tells you the y if you know the x?
yeah, y equals e raised by 2x.
You are missing something, yes, yes.
Y is e to the power of 4.
Look, listen carefully to my words. Listen. Do you have a formula that tells you what the y is if you know what the x is? Huh?
Do you have a formula? There is the formula right
I'm
there.
lagging.
Are you using e to the power of 4?
He said no log.
E4.
Yeah, e4.
E4, why is E4?
Yeah.
Because x
It's
is
equal
equal
to
to
2.
Y is e power 4.
Yeah.
Daniel, did you see that? Y is e power 4, yes?
Oh.
Oh, buffering has finished.
Yeah. I put a light
Information has caught up. We're streaming again. High def.
I'm not wireless, I put a light cable.
I see, alright, yeah. Okay, so we continue now. We'll need to get the m. So what is the derivative here?
2e.
Yeah, 2e2x, and the x is 2, so it's 2e4. So, I mean, you can put it as a decimal if you want, but I'll leave it like this. Y equals mx plus c, and I'll need to sub this in. So it's E4 equals 2E4 times 2 plus c. So that's E4 equals 4E4 plus c. So c would equal minus 3E4. Because it's like you have one of them here and you remove 4 of them. So y equals 2E4 x minus 3E4. That's the answer here. Yeah. Say again? It is. Yeah, it is. Yeah.
We do have our initial exams, initial exams. We have our nominal exams, first semester exams before the break, right?
I think it's after, but I'm not 100% sure.
You were the one who told me that.
Well,
I'm having a problem with these teachers saying that they're
is it before?
No, it's after.
That's what I said.
Yeah, you said sure.
And you
No way you can get finished.
Actually,
Yeah, then I told you it's not. And I said usually.
I think English is before because it
Yeah, yeah, that's it. English is before, and the other 3 are after.
Yeah, I think so.
before after. So you know the level of work happening now.
Yeah. But that's what I said.
I thought I heard you say before.
Ah, no, you need to listen. All right. We got that written down? Yeah. Now, I'll give you a smaller example like this, because I want to show you why tangent lines are actually useful. So, here's a similar one. I don't want to make it too similar to. We'll say y equals square root x, and I want the tangent line at 1, 1. It's a little easier.
We're looking for the equation of the tangent line, right?
Yeah.
Square root is not in the directive list.
Oh. Loading.
Oh yeah. اسكت يا أخي أنت شرف.
Yeah. Chub.
No, because
Chub your
I
face.
concentrate.
What do you mean you can't expect to think inside of this?
No, just
man.
I learned this one. What's so funny? If he can use a little bit of Arabic, why can't I, Yanni? That's what the problem is. My accent. How do I have bad words? I just won't say them. Right, do we have an answer here for this?
Yeah. Y is equal to half x plus half.
Half x was a half, is it?
Yeah.
So, the trick here was to say x power a half, and dy dx is a half x minus a half, and the x is 1. So this ends up being a half, and that's the end. So you have y equals a half x plus c. We get to c by putting this point in, which, yeah, it'll be 1 equals a half plus c, so c equals a half. So you have y equals a half x plus a half. Now, I did this example because I want to show you one reason why tangent lines are actually useful things to know. Or I might need to give a minute Can I scroll down, or do people need to write this? Yeah, okay. Yeah, that's okay. Yes.
For example, if I have x raised to the power negative 2,
Yeah.
and I want to do like the y
Derivative. Yeah. Be
differentiate
minus 2x minus 3.
minus 3.
Yeah.
Oh, so you put minus 1 to the power, you minus 1 to the power.
Yeah.
Every time you always put minus 1 on the power.
Yeah. Okay. Do we have this written down? Yeah. Yeah. Right. So, as I was saying, why are tangent lines useful? Let me show you an example or an application of a tangent line. This one in particular. So let me just quickly sketch what we have. There's x, there's y, and then this is the curve y equals root x. And we have here marked off the point 1, 1, and we have here our tangent line, which, let me put it in a different color, looks like this. So this is y equals a half x plus a half. Now, what would happen if I put x equals 1 into this formula? What do I get for y? I get 1, obviously. Square root of 1 is 1. What happens if I put 1 into this formula? A half plus a half. Yeah, but that's not really surprising. But this is the insight. You realize if I'm near 1, like say I'm here at 1.1, then the value I get for my square root and my value I get for my tangent line, they will be different, but they won't be very different. Because if I move only a little bit to the left, I'm in a situation where they're the same. So in other words, we can see that a half x plus a half is roughly the same thing as square root x if x is near what number? If it's near 1. And in fact, when x is 1, then these are the same. Because square root of 1 is the same as a half plus a half. Okay? Now, I want to show you this in action. So, let's say, for example, I want to calculate what square root 1.1 is. Now, if you didn't have a calculator, you could use something like this to roughly calculate it. So, apparently, it should be roughly the same as a half of 1.1 plus a half, which is equal to, what's that, 0.55 plus 0.5, which is 1.05. Now, I want you to take out your calculator and compare that to square root 1.1. And let's see how close we are. So what was the error? Well, what was square root 1.1? 0.48. So the error will be... Okay, hang on. Wait. 1.0... Okay, that's fine. 498. Okay.
No, 488 or 49.
Oh, okay. 488 we'll go with. Okay, 488 then. Right, so, and we needed to get 1.05. So the difference between the two is 0.022. Is that it?
No, one.
Oh, sorry, 1.
Also 0.001.
122. Do I have the right number of zeros here? Could you just hit it in and make sure? 1.05 minus...
1.2 is multiplied by 10.
Oh, thank you. You've got the difference there. Right, no, I'll write it exactly down. Error is 0.00119. Yeah. That's quite a small error. So, it's good when it's close. No. And this is one of the reasons tangent lines are useful, because imagine you had a situation like this where you had some rather complicated function, but you knew, for example, that all the values you're interested in are, say, just between these 2 points. Well, if you've got a tangent line here, you could use the tangent line instead. This is a very common trick in maths when you want approximations. You use tangent lines to give you approximations. So we actually call this, you can think of it as, let me see, a tangent line is like a linear approximation. So you replace a difficult function like square root x with a simpler linear function like a half x plus a half. But of course it's only an approximation, which means it's only good in certain regions, in this case when x is near 1. And you can actually describe it as convergent, that when x moves towards 1, our square root also moves towards 1. So they converge to be perfectly right at 1. Okay. So write this one down. Now this is a little bit more advanced than what you need in the exam. Often in the exam they simply ask you to find the tangent line. And they have you do some stuff with the tangent line, but it's stuff you already know. For example, a common question would be to ask you as part 2, where does this tangent line cross the x-axis? Well, that's easy. So how do we find out where this one crosses the x? Y equals 0. So in this particular case, what would it be? It cross at x equals minus 1. And another question might be, where does it cross the y-axis? Well, in this case, where would it cross the y-axis? At a half. Okay. So again, this is really all familiar stuff for you. The only thing that's additional today is the use of the derivative to calculate the slope. That's all that's really extra, right? There's nothing particularly extra.
Will it tell us to calculate the tangent using the
No. They expect you to use the derivative always. Yeah. Okay. So what I don't need you to do the second half. I just need you to do 1 to 10. Okay. They're all quite short. Yeah, they're all quite short. No, actually 1 to 10 is too much. Just do 1 to 5. 1 to 5.